Okay, good morning. Week 12. Today's not Monday. Come on, wake up. Tuesday. Right. So last week, I finished off mentioning to all of you why 3D Mo circle is important. Okay. And you witness why is it so critical? Yes or no? Right? If you ignore it, you might underestimate your stress state in your structure that's loaded. Now, when we begin our lecture on week 1, if you were to recall, you have seen this table. Yes or no? So this is from week 1. You have seen this table, right? Remember we started this, and all of you thought that from here on we are going downhill. Yes or no? Now, what are the stresses shown down here? Okay, let me highlight this first. Okay, so as you can recall, we are focusing on steel. And on the first column, we have ultimate strength. And on the second column, or the third column, I apologize, you have our yield strength. And I make you aware that this is only good for brittle material. And the yield is the one that we're going to use for ductile material. Now, how is this linked to Mohs circle? Yes or no? Right? It should be linked. Okay, but how are we going to link, or what's the relationship between the table over here to what we see of the stresses of the element that we calculate over the past 2 weeks? Okay, so I'll pick, just for simplicity's sake, I'll pick yield strength at tensile. So we know during our tensile test, we have a cylindrical, this is our test piece. And over here, this is our centroid, geometric centroid. And then I'm going to construct that this is our element. Okay, so we know that this direction, I call it our X, our Y, and this direction is our Z. And if we're and this structure over here, as the word says, is under tensile test. So you got P, you got P prime, and over here, this is our cross-sectional area. Okay, A, right? So if now we were to construct or take out our element, right? Now if we were to take out our element, so we have our element over here. This is our X, this is our Y, and this is our Z. And if we were to take out this element, what we see over here, that this element over here have P. So I'm going to call this PX, okay? Can you all change to PX, please? So we're going to have PX over A. And that's the only stress state that is available. The rest is equal to 0. So what we have over here, now we're going to construct 3D Mohs circle. We're going to label this as our point X. This surface over here, our point Y. This surface over here is our point Z. So when we construct 3D Mohs circle, how does it look like? Okay, so I'm going to go into 3D Mohs circle. So we know that this is our normal stress. This is our stress X, or normal stress, sorry. And then we have our shearing stress. Okay. This is our shearing stress. Element rotate clockwise. Element rotate anti-clockwise. And at a certain point, over here, this line is our Px over A. And we are aware that this is our point X. And our point Y and point Z on the element on Mohs circle, they have zero what? They don't have any what? Stress state at all. So this is our point X, sorry, our point Y, and also our point what? Our point Z. From here, we now can construct Mohs circle. Now what you see over here, this is a what? 3D what? This is also a 3D Mohs circle. Okay. But what is more important now is this point over here. I'm going to call it stress A. And this point over here, I'm going to call it stress B. Okay. So what we realize is stress A and stress B are the what? Principal stresses. Okay. So why are we doing this for? Okay. Now, if we were to go back to our table now, if we were to go back to our table, this is our what? Sorry. Over here, these values over here, in tension, what is given to us are the what? Are our what? Principal stresses. Are we clear? Okay. Only if you know what has been given on the table, then you know what to choose. Okay. So all these cases, you can see that you have what? Over here you have tension, and over here you have what? You have shear. Yes or no? Right? So all these tests, all these tensile tests, all these tests are all what? You need what? Directional. You can either do it in tension, or you can do it in compression, or you can do it in what? In shear. It's very difficult to do what? Compression and shear at the same time, or tension and shear at the same time at low cost. Okay, it's possible, but your cost will go crazy. Imagine how many materials you have. Okay, so what I want you to learn is, if there is no material properties available, at least you know what to test and what to measure and what you're measuring. Are we clear? I think you're going to have a lab in your measurement. You're going to do tensile tests. Now at least you know what you are measuring or what you're testing on. Okay. Right. So we have seen on what this table shows. Okay. So now, if we're going to pick a stress state, okay, I don't know which week. We are going to pick a stress state, okay. So this is our element A. So we are going, what I'm going to do is we are going to deal with element A, okay. So this diagram over here, this is week 11 on a Tuesday, okay, week 11 on a Tuesday. So we are going to pick element A or element B, either one. Let's pick, both are as good or both are as bad, I don't know, okay. So let's pick this one. Oh no, let's pick, this one has better, this one looks better. Okay, let me, wait, now it don't work, pardon me. Again, don't work. Ay, 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 ay. Better now. Okay. So this is our element, one of our element. I think this is our element B. So remember we did this, right? We take a while. Okay. This is our element B. Okay. So this is our element B. And then this is our respective transformation. This is our X. This is our Y. And then this is our what? This is our Z. Okay. So now we are going to construct what? We're going to construct 3D mole circle. Okay. On this aspect, you're going to label based on our transformation. This is your point X. Over here, this is your point Y. And over here, this surface is your point Z on mole circle. Okay. So now we are going to construct mole circle. So I have 19, I have compression. Okay. So I'm going to sketch. So again, we have our normal stress, right? And then we have our shearing stress. And I can see it's more focused on compression. I'm going to reduce my size on the what? Tension. Okay, so I have 14. Okay, so this would be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 negatives. Then you have 2, 4, 6, 8. Normal stress. Shearing stress, element rotating clockwise, element rotating anti-clockwise. So this is 2, 4, 6, 8, 10, 12. What is my shear at? 14. Oh, I might need a bigger circle. Hold on. Let me see. 0. Okay, I'll start with it. 16 minus 2 minus 4 minus 6, 8, 10 minus 12 minus 14 and minus 16. If not enough, I can shift a bit. Okay, if not enough, we can shift a bit. I'm going to shift. I got a bad feeling about this. A real bad feeling about this. Okay, I'm going to shift it here. Okay, so we know that we have a, gee, I got shear until what? 20. Okay, yeah. Okay, pardon me, okay? This is not a cooking show, this is live. Cooking show, you know where to stop. Live, you just make mistake. Okay? 16, 18, 20, you know what? Yeah, I don't waste your time. Sorry, people, my bad. My bad, being too ambitious. I'll make my life simple. Okay, I don't make your life difficult. My bad. I thousand apologies. Okay, this is just a sketch. Okay, because we calculate more accurately. So I'm going to go in fives. So normal stress